Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 5, Part 1, Section 1, and this is about the structure of the atom, and Section 1 is, well, that the atom has a structure. So quickly going over what we've done before, Chapter 1, we learned about chemistry is about discovering and understanding natural laws using the scientific method, and energy cannot be created nor destroyed. In Chapter 2, we talked about matter can be mixtures or substances. The smallest unit of a pure substance is an element, like the most elemental or fundamental part of pure substances. And each element is a type of atom, and they are arranged in a periodic table. Atoms come together to form compounds. Atoms with an electric charge are known as ions. And just in Chapter 3, we learned temperature is a measure of kinetic energy. Heat is thermal energy. And heat gain and heat loss can cause phase changes as those molecules are rearranged. And in Chapter 4, we learned in physical changes, the molecules are rearranged, and in a chemical change, the atoms are rearranged to make new substances. We learned chemical reactions can be endo or exothermic, and many reactions occur in aqueous solutions, and that some elements are more reactive than others. So the question is, how can we explain the properties and behaviors we have observed? Well, the answer is found inside of the atom, so we're going to dive into the atom. Each element has unique atoms. Well, how did we discover this? How did scientists discover that? All right, it started a long time ago in this galaxy. We're going to about 400 BC, so about 2,500 years ago, starting with ancient Greeks. And there was this guy, Democritus, and he had this thought experiment that you could divide something in half, but you cannot divide it in half forever. At some point, you're going to come to a fundamental part of that matter. And that fundamental part of matter is an atom. So, evolution of the understanding of atom. There we go. Please write this down. It started with Democritus, which was about 400 BCE, before the Common Era. And he was a Greek philosopher. And he had the idea that you can't divide matter forever. And he named that indivisible piece an atom. So we got the idea and the name from Democritus about 2,500 years ago. Okay, then we're going to fast forward about 2,000 years, nearly 2,000 years, to the early 1800s, to John Dalton. He was the first person to come up with the modern atomic theory. So please write this down. John Dalton was in the early 1800s, and he came up with the atomic theory, which, you don't have to write this down, but it's still true today, so he got a lot of things right. Just telling you a little bit about Mr. Dalton. He was a super smart guy. He started teaching at the age of 12. He was an English teacher, but he also experimented on all of these different things. He studied color blindness. He came up with the law of partial pressures. So he was involved in a lot. Now I would like you to write down the atomic theory, please. So write down Dalton's atomic theory, and starting with number 1, all elements are made of tiny indivisible particles called atoms. And then write down number 2, all atoms of the same element are the same but different from atoms of every other element. Number 3, chemical reactions rearrange atoms but do not create, destroy, or convert atoms from one element to another. So in a chemical reaction, the atoms are rearranged, but you have the same exact atoms. Same number, and the same type. And finally, number 4. Compounds are made from combining atoms in whole number ratios. Like water is H2O. 2 atoms hydrogen with 1 atom oxygen. So, atoms are made from even smaller particles. Our indivisible atom is divisible? What? Yeah, so we have the proton, neutrons, and electrons. And we can say the atom is the smallest part of matter because once you start splitting atoms, then that element no longer has those properties. So only an oxygen atom has properties of oxygen. If you get into oxygen protons, neutrons, electrons, they're the same regardless which atom they're in. So how did scientists discover this? Well, I'm glad you asked. Let's start about 75 years later. There was this guy, William Crookes. He invented a tube called a cathode. So where it's basically a vacuum where the gas has been removed, and then under a high voltage, a ray, like an array of electricity, was emitted from a cathode, which is, like anodes and like positive and negative ends of electricity. So you run electricity through this like vacuum gas tube. So then scientists just played with it. We're looking at 1897 and J.J. Thomson. And so it's about 100 years after Dalton. And he was playing around doing experiments and was shooting electricity through this. And then he put a negative magnet and a positive magnet. Like he had negative and positive plates that he put on either side, and he saw that the ray always bent away from the negative plate and always towards the positive plate. So he was like, that ray has negative particles. So please write this down. J.J. Thomson was around 1900, and he did experiments using cathode rays. And he discovered and named the electron. He also, during his experiments, found that electrons are particles inside atoms. The electrons are negative, and they have to be very, very small. And he was right. All right, let's go about 10 more years into 1910, and Ernest Rutherford discovers the nucleus. So let's talk about this experiment. So they had alpha particles, which is basically like a helium nucleus. So it's like 2 neutrons and 2 protons. It's a type of radiation, and it would be a positive because it's got 2 neutrons and 2 protons, but no electrons. So they're shooting these small positive particles at a very thin, very, 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 very thin sheet of gold. And since most of the atoms are open space, a lot of those teeny tiny particles just went right through. However, every once in a while, one would like come back, and that was really interesting to them. So they're like, hey, what's going on here? So please write this down. Ernest Rutherford in the early 1900s discovered the nucleus, discovered that the nucleus is positive and it's dense and it's small compared to the volume of an atom. So the reason they knew it was small compared to the volume of an atom, so we know that matter is made out of atoms, but most of those alpha particles went right through. So the positive nucleus had to be small and dense and compared to the rest of the atom so that most of them could go right through. And then it also had to be positive because it would hit, the alpha particles would hit that nucleus and jump back. So since the alpha particles were positive, then they would reflect back, and it had to be dense so that the way that the particles reflected, we knew it had to be dense instead of just like being deflected, it actually like came back towards them. So this analogy was that it was just like they were shooting a shotgun at a Kleenex and the bullet came back to them. This is how mystifying the results of their experiment were at that time. And we just want to give a shout out to Marie Curie. She had been experimenting with uranium and found it was radioactive and that it emits alpha particles, which gave them the source of the alpha particles to use for the experiment to discover the nucleus. So, good job, Marie Curie. Okay, please write this down. Atoms are small particles that make up all matter and are made of subatomic particles. That is the protons, which are positive, the neutrons, which are neutral, and the electrons, which are negative. So taking a look at our atom with the electron cloud here, and then zooming out to the nucleus with the neutrons and protons, we know the protons are positive, neutrons neutral, electrons negative, and that if you have the same number of protons as electrons, then they're going to cancel each other out, and you have a neutral atom. So let's dive into the nucleus. Protons and neutrons are in the nucleus. Please write this down. The number of protons determines which element, and if you change the number of protons, you change the element. And the number of protons is called the atomic number, and it's found in a large, bold number on the periodic table. So talking about the protons and neutrons together, the mass number is the number of protons and neutrons in one atom. The average atomic mass is the average of all of the mass numbers of that element in the world. So the atomic mass is the average mass of one atom of that element. So, and we measure it in AMU. And then, the molar mass is the mass of 1 mole of that element, and we measure it in grams. Both of these numbers are found on the periodic table. So for example, carbon is like 12.011. And so the average atomic mass of all the carbons in the world is 12.01. So the average mass of one carbon atom would be 12.01 AMUs, and then the mass of a whole mole of carbon would be 12.01 grams. All right, so taking a look, we have our atomic number, that's the number of protons, and then we're going to be getting into, the mass number or the average atomic mass. So the neutrons act like glue to keep these positive protons in the nucleus. So we know that protons are positive and they kind of want to repel each other, so you need a neutron glue to hold them in there. So we've got our 6 protons, and then in carbon-12 we'd have 6 neutrons, so that gives us our mass number. A mass number is a whole number, and an average atomic mass is a decimal, like 12.01. So please write this down. Protons repel each other. There must be a force that keeps the nucleus together. So the protons are repelling each other. What is that force? It is the strong nuclear force. So the strong nuclear force attracts particles together in the nucleus. It attracts protons to protons, protons to neutrons, and neutrons to neutrons. It is very, 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 very strong. It is 10 to the 40th. So 10 with 40 zeros times stronger than gravity. So if it's so strong, why haven't you heard about it? Well, because it only works on very, very, very small distances. The strong nuclear force is only applicable within the nucleus. So that's why it doesn't affect us. We're not going to jump out of a building and fall to Earth because of the strong nuclear force. So gravity is super weak compared to the strong nuclear force, but on a day-to-day life, the strong nuclear force doesn't affect us. So that's why you may not have heard of it if you have not. And it is one of the 4 fundamental forces. So it's the electric force, magnetic force, those are 1, electromagnetic force, gravity, strong nuclear force, and the weak nuclear force are your 4 fundamental forces of the universe. Okay, in our next video, we are going to talk more about the nucleus and electrons. So not so much about the nucleus, more about electrons.